So based on what you said, what I understood is that it is possible for ChatGPT to get there. It's just not there now because you need to plug in so much information, which as humans we've picked up from all these different senses and different things that we've experienced through life. That's how we have made these different inferences. We know the difference between if somebody asks you what time it is, the setting is going to make a difference. So if ChatGPT had that amount of information to build it, then maybe eventually it can get there. But right now, we're nowhere close to that. Is that true? Is that what that meant?
So I think that that is true to a certain degree. If we could recreate the human brain in silicon or in programming, we would be able to have a machine that did what we do. The approach of AI companies like OpenAI or Meta, Gemini, whatever, the approach that they're taking is they're starting out with a model and allowing the world to tell it what it should know. It's using the experience of lots and lots of training data to be able to pick up on statistical associations in that training data. Now, if there was everything objectively there in that training data that would allow them to pick it up, then it might be possible for that strategy to be successful. The problem is that that's not how we come to behave the way that we do. And it's not even possible in principle to arrive at a human-like representation from that kind of training. There's a thought experiment in philosophy that I think illustrates this nicely. It's called the Gavagai Problem. Imagine that you were an astronaut that landed on an alien planet. And when you got there, a little alien came up to you and pointed off in a direction and said the word Gavagai. Now you follow their point and you see that they're pointing at what looks to your eyes like a plant. What should you infer from that information? We're very tempted to respond, well, it's obvious. They're referring to that thing as a Gavagai. That's what that plant is. In fact, it's not the name of that plant, it's the name of that plant species. If we saw something else that looked like that, it would also be a Gavagai. However, that's not the only possible thing that might mean, right? The alien could be pointing and saying, that's dangerous. The alien can be pointing and saying, that's the Gavagai color. The alien could be pointing and saying, this is my pet Gavagai. And that individual thing's name is Gavagai. In fact, there's an infinite number of possible things that any piece of information could mean. There has to be some pre-specification of the hypotheses that you're going to form in advance, some pre-specified narrow set of inferences that you're going to make from any piece of information for you to actually learn anything. The incredible power of the human mind is that we have lots of those pre-specifications built in. For example, we have that pre-specification that when we hear something like that alien pointing and saying the word Gavagai, we interpret it as naming. We interpret it as naming a category, not other information about the thing and not specific information about that specific individual. That's a very useful pre-specification to have. That's actually a very efficient way of learning words. So if we both use that when we're teaching people things and we use that when we're learning from others, that's going to be a very efficient way of transmitting a language from one generation to the next. But without having that constraint built into the system in advance, no matter how big the model is, how powerful, no matter how much training data it has, it's never going to be able to test all of the infinite hypotheses for all of the infinite pieces of information it has, or very large number of pieces of information that it has, to be able to recreate a human mind's worth of knowledge. Trying to tie this back into how the question started. Now, we can see these constraints and this pre-specified information all throughout our brains. We can look at an object and just from the experience of seeing the front of it, make inferences about what the rest of the object looks like, right? We can infer that it's from the fact that I'm holding it, you're inferring that it's light enough to hold. From the fact that I'm pinching it like this, you're inferring that it has that same shape all along the back. Because objects tend to be a consistent color unless there's a good reason for them not to be, you're going to infer that it's also purple on the back. Our brains make all kinds of assumptions when we see information. And those assumptions, they work because they've picked up on true things about the world that have been true for millions, if not billions of years. Now, these models could potentially have all that training data. But the question is, are we going to be building the model in such a way that it can pick up on what it should be picking up on? And I think that's going to be a real challenge if we're going to get anything approximating a general intelligence.